Exercise 8.1, Problem 5, Discussion. Let's read the problem. The total surface area of a solid right circular cylinder is 231 cm square. Its curved surface area is 2/3 of the total surface area. Find the radius and the height of the cylinder. Okay, good. So now let's list out or underline what is given in the problem. 231 square centimeter, that is the total surface area, is a cylinder. What else is given? Curved surface area is 2/3 of the TSA. Okay, I think this is all is given. So let's write it out. TSA equal to 231 centimeter square. CSA is equal to 2/3 the TSA. That is 2/3 into 231 will give you the curved surface area. Next, what are we asked to calculate? We are asked to calculate radius. We are asked to calculate height. So these are the two things which we are asked to calculate. Let's write it out. Radius and height. Now think about the formula which will connect the radius and height to this TSA and CSA. But this is a special case because CSA is given as 2/3, so we'll have to do it little differently. Anyway, let's list out all the formulas. Curved surface area is 2 pi r h. TSA is equal to, we normally have that formula 2 pi r into h plus r, but this is a different case. You can do it that way also. I'm trying to show you how to do it this way. Okay, TSA is curved surface area plus 2 pi r square. See, total surface area is equal to curved surface area plus bottom plus top area. Bottom and top are circles in the case of a cylinder, and area of a circle is pi r squared. So it is bottom and top is 2 pi r squared. So curved surface area is CSA plus 2 pi r squared. Then this is a special formula here for this particular problem because it is given curved surface area is 2/3 TSA. So these are the three formulas which we are going to use here. But the very look of it, CSA is equal to 2 pi r h. This cannot be calculated, it cannot be used because CSA, if you want to calculate, you should know R and H. Both are not known, so which means we cannot use this formula. Now come into this, TSA equal to CSA plus 2 pi r square. Again, we cannot use this because we don't know CSA, nor do we know R. So this also cannot be used. But come to this formula, CSA is equal to 2/3 TSA. This can be worked out because TSA is known. So TSA is given as 231. So which means 2/3 of 231 is CSA. Okay. So once we know CSA, you come into this equation. TSA is already given 231. CSA we have calculated here. So which means radius is to be calculated, and that can be done because this is only one unknown variable. Once we know radius, come into this formula. CSA equal to 2 pi r h. CSA we have calculated in this step. Radius we calculated in this step. So h is the only unknown, which means we can calculate using this equation. So let me repeat. We calculate first CSA, then we calculate R using this formula. Once we know CSA and R, we calculate height using this formula. So let me summarize it for you. Calculate CSA using CSA is equal to 2/3 TSA, where TSA is equal to 231 centimeter square. This is a special formula which is given in this particular problem because here they say the curved surface area is 2/3 of the total surface area. So this is only applicable to this particular problem. Okay, so when you substitute 231, you will be able to calculate CSA by multiplying it by 2/3. Next, substitute the values of CSA, which we calculated in step 1, and TSA, which is given 231, in the formula TSA equal to CSA plus 2 pi r square, and calculate R. Only R is the variable which is unknown, so we will be able to calculate radius. Step 3. Substitute the calculated value of radius from step 2 and CSA from step 1 in CSA equal to 2 pi r h and calculate height. Okay, so this is how the problem is to be done. Okay, what I suggest is you stop the video, pause the video here, and try to work out the problem on your own, looking at the steps. Now we have the solution. The solution get given TSA equal to 231 centimeter square. CSA is given as 2/3 TSA. So CSA will be equal to 2 by 3 into 231. 3 will go 70. Sorry, 2 will go 7 and 7, 77 times. So 77 into 2, that is 154 square meters, meter square. That is the curved surface area. Now look into the formula. TSA equal to CSA plus 2 pi r square. Look into the normal formula. TSA is 2 pi r into h plus r. You might be wondering how you got this formula. Logically, total surface area is curved surface area plus top and the bottom area, which are circles. So pi r square plus pi r square, that is 2 pi r square. And if you look into the formula also, you'll be able to get the same. TSA is 2 pi r into h plus r, that is 2 pi r h, and plus 2 pi r square. That is 2 pi r h is CSA. So TSA can be written as CSA plus 2 pi r square. Okay, so this is another way of writing the same formula. So TSA equal to CSA plus 2 pi r square. So we'll substitute all the values. TSA is taken as 154. CSA we have calculated in step 1. That is, I'm sorry. Sorry. CSA is 154, which we calculated here, plus 2 pi r square equal to TSA, which is 231. So substitute all these values. So 2 into 22 by 7 into r square will be equal to 231 minus 154, that is equal to 77. Our r square will be equal to 77. This 7 will go up. So 70 and 22 and 22 will come down. So 77 by 22 into 7 by 2. 11 will go 7 times and 2 times. So r square equal to 7 by 2 into 7 by 2. So r will be equal to 7 by 2 centimeters. Okay. So one part of the problem is done. Radius is calculated. So let's go to the next one. Step 3. CSA equal to 2 pi r h. Now we know already the value of radius, and CSA is also known. So which means using this equation, we should be able to calculate the value of height. So 2 into 22 by 7 into radius, which is 7 by 2 calculated earlier, into h will be equal to CSA, which is 154. So keeping h, transfer all the other things, other numbers to the right hand side, we'll get 154 divided by 22, because the 7 and 7 cancels, 2 and 2 also cancels. So 22 is only left out here. So when it goes to the other side, it comes in the denominator. So height will be equal to 154 divided by 22. That is equal to 7 centimeter. Thus the radius and the height of the cylinder are 7 by 2 centimeter and 7 centimeters. Okay, that's all in this problem. Thanks for watching.